End users can readily provide demonstrations of tasks desired of robot. However, it is burdensome to require a sufficient variety of demonstrations from end users to make the robot robust to perturbations experienced in real-world environments. In this work, we approach the problem of one-shot task execution, where a robot is provided with a single task plan and attempts to execute that task plan in other perturbed environments. Our framework does this by coupling provided task plans with domain knowledge. By integrating the task plan with generic semantic knowledge, the robot can be more robust to changes in the environment, like misplaced or missing items used during the demonstration. In our experiments, we first provided the robot with a single task plan that serves as a demonstration using a hierarchical task network. Then the environment is perturbed and the robot attempts to repeat the task in the perturbed environment. We exhaustively tested our approach both in simulation and on a physical platform in the task domain of household cleaning using the virtual home simulator and fetch robot. Given a single demonstration, our approach robustly executed in over 73% of our sampled simulation environments and 76% of our sampled robot environments. To achieve this performance, our approach iteratively updates the task plan using task generalization reasoning. After being provided the single task plan and being instructed to repeat the task plan in a new environment, the robot eventually encounters a primitive action failure due to the environment perturbations, which invokes the task generalization module. Task generalization reasoning is then done using the domain knowledge to substitute task plan constituents and continue execution. This process repeats as needed until there is an execution success or the task generalization module runs out of likely generalizations. In our approach, we selected a knowledge graph embedding to model the domain knowledge. Knowledge graph embeddings model the domain knowledge as a graph in vector space, which enables modeling large-scale and sparse domain knowledge graphs. Because the embedding models many relationships between concepts, the robot can reason about more than just alternate locations for objects. In addition to alternate locations for objects, the robot can reason about alternate objects that can be used for the same actions, alternate actions that can achieve the same effect, and other relationships. Lastly, by modeling the graph in vector space, the robot can infer relationships not present in the training data, which further promotes generalization. Please follow the links provided to access data to train the knowledge representation, code for domain knowledge models and evaluation and simulation, and pre-trained domain knowledge representations that can be used immediately to perform inference.